Students, so today as discussed last time that we have to start doing the numericals of this chapter as theory regarding moments and forces have been completed. So you can see the first sum reads that a mechanic can open a nut by applying a force of 200 tons. In doing any numerical, first read the sum very carefully because certain numbers are given, certain data is given in words. So sometimes students are not able to use the data which is given in words. So better you can first write the data, like in this sum the data is given a force of 200 Newton. So you write force is equal to 200 Newton is given. This force is equal to spanner of length. Length is equal to 25 centimeter. So when force is given, length is given. So what is not, how long span is it? So how much would be the moment of the force required to open the nut? So if we write the formula, moment of force required to open the nut is m equal to F multiplied by L. So if you multiply, you will get 200 multiplied by 25 Newton centimeter. Write the unit, this is in Newton, this is in centimeter. So this is the moment required. Now whosoever wants to open this nut, he has to supply this amount of moment. Now a boy is able to give only a force of 50 Newton, but Newton meter, so again write the formula. Again write the formula, m equal to F multiplied by L. Now in this case m is known. How much is m? 200 multiplied by 25. So 200 multiplied by 25 and force is 50. What is the length? So you will get L equal to 100 centimeter. Is it alright? So in this manner, numericals have to be done. Write down the data. First force is 200 Newton, length is 25 centimeter. So find the moment required. You should write the full sentence. Moment required to open the nut is equal to F multiplied by L equal to 200 multiplied by 25. So Newton centimeter. Now again m is equal to F multiplied by L. If we apply a force of 50 Newton, then we will get L as follows. So put the value of m as 200 into 25 equal to 50 into L and get the value of L. Is it alright? So then we will go to second sum. Second sum is door is 1.4 meter broad. So this is the door. This door is 1.4 meter broad. So we will assume the door is fixed at this stand. This is my door. Okay. So it can be opened by force of 100 Newton at the middle. So I am giving the force in the middle here. So what is D? Small d in this case would be 1.4 upon 2 because I am giving the force in the middle, that is 0.7 meter. So this is my D. And what is the torque or moment of force is also known as torque. Torque is equal to F multiplied by D. Okay, question is how much is the torque? So because I know the force, I know D. So I will come to know the value of torque. So torque required is, force is how much? Force is 100 Newton multiplied by D is 0.7. So that will give me 70 Newton meter. So this is the torque required to open the door. So it says calculate torque required to open the first part we have answered. Minimum force required. So when will force would be minimum, torque required is going to remain same. So I want F to be minimum. So D should be maximum. So D maximum is 1.4. So the minimum force required, for that I will write torque is going to remain same 70. So what I will write, 70 equal to, what I will, so I will write 70 equal to, 70 is equal to, force I don't know and our distance is 1.4. Therefore, F is equal to 70 upon 1.4. And if you calculate this, you will get, this will become 700 upon 14. So this will become 100 upon 2. So this will give me 50. So force required is 50 Newton. So if you are applying the force of 50 Newton at the end, maximum D, then this is the minimum force required. Is it alright? So now we'll go to next numerical. A uniform seesaw. You know what is seesaw? Is supported at its center. Okay, so this is seesaw. It is supported at its center. This is the center. It is supported here. A boy weighing 30, this is 6 meter. Total is 6 meter. This is 6 meter total. A boy weighing 1.5 from the center. You should be careful. He says 1.5 from center. So here is a boy and his weight is how much? 36 kg. So 36 kg is the mass of the boy sitting at 1.5 meter from the center. Where must other boy? 27 should sit. So 27 kg. So 27 kg, mass of the boy is less. So distance has to be more. So I will show something at a more distance. So here a boy of 27 kg is sitting and distance is how much? That we want to calculate from the center. So here now it is in balance. You can even use principle of moment. W1 into L1 equal to W2 into L2. Or you can say taking moment about center, taking moment about the center, you will get this moment is in anti-clockwise direction and this moment is in clockwise. So by principle of moment, clockwise moment equal to anti-clockwise moment. So 27 multiplied by D is equal to 36 multiplied by 1.5. So D would be 36 multiplied by 1.5 upon 27. So you can calculate this, you will get this as 2. So the distance is 2. 9 3s are 9 4 the, then 3 into 0.5. So this will come 2 with 2. So 2 meter. So in this manner, you have to do the numerical. Now let us do the next numerical. First read the sum carefully. Is uniform meter rule. Now you see the data is given in the words form. Uniform means the weight of the ruler will act at the center. Meter rule. So the length of the rod is 100 centimeter. So my length of the rod is 100 centimeter. So length of my rod is 100 centimeter. So 100 is at this end and 0 is at this end. This is 100, this is 0. Now it is supported at 40. So 40 would be somewhere here. So I write 40 centimeter here. This is 40. And here I have got my knife edge. So this is my knife edge. at 40. Okay. Now the weight will act at 50. So this is 50 centimeter. So here my weight will act, means mg. The mass is mg. This is weight. So weight of the ruler will act here at 50. Now he is suspending a mass of 10 gram either at this end or at this end. Then we have to decide that at which end he has suspended for the ruler to remain in equilibrium position. So this 50 gram will create a moment in which direction? In clockwise. So my suspended weight should create moment in the opposite direction, means in anti-clockwise. So means it has to be at 0. If it is at 0, then this 10 gram force will create the moment in anti-clockwise. Then only it can be balanced. If I put suspended it here, then both will be clockwise. The ruler will be down from this end. Is it alright? So first part we have done, we have drawn the figure. So at what end must be suspended? At the end where there is 0. What is mass of this ruler? Now this ruler is in equilibrium. Therefore clockwise moment is equal to anti-clockwise moment. So this 10 gram force, what is distance for this 10 gram force is 0 to 40 centimeter. Therefore 10 mass is 10 gram force, 10 into 40 equal to, and here what is the weight? I don't know. So I will say W. So what I will say here? I would say here W. So weight is W, and what is the distance? Distance of this weight is 10 centimeters. So I will write 10, and here it will be 10 gram force. So also here it will be 10 G, acceleration due to gravity. Therefore weight M is mg. This is 10. This is 10 G. This is 40. So G will cancel from both the sides. 10 will also cancel. So I'll get M is equal to 40 gram. This G is gram. This G is 10 G is the force. So G is acceleration due to gravity. So this is how this sum is to be done. Is it alright? So then we'll proceed to next sum. Two forces, each of magnitude 10, are vertically upward and downward. So one is vertical up, other is vertical down on ends of a rod 2 meter long. So there is a rod. Now this rod is 2 meter long. One force is says upward and one force is downward, and both are 10 Newton. This is also 10 Newton. This is also 10 Newton. Rod is pivoted at its center. So at center it is pivoted. So this distance is 1 meter. This distance is also 1 meter. Calculate the resultant moment of force over midpoint. So what is the moment of, if we take moment about this midpoint, this force will give in which direction? Clockwise. This will also give clockwise. So what we will say? Both the forces will give moment in clockwise direction, and this force will give 10 multiplied by 1, and other clockwise, and other will also give 10. So let us continue our numericals. So now we will do question number 6. In question number 6 reads that a physical balance has his arms of length 60 and 40. So balance does not have arms of same length. One is bigger, one is smaller. So the question is, what weight must be kept on a pen of longer arm? So let us draw the, so there is a long, so let us draw the figure. So this is the figure. Suppose this is 40 centimeter and this is 60 centimeter. So the balance is not of same length. Here I will be keeping the weights. Okay, so the question reads, let us go back to the question. What weight must be kept on pen of longer arm? 100 gram is kept on the other one. So 100 gram force is kept on the other arm. We want to find the weight in the longer arm. So 100 gram is kept on the shorter arm. We have to find the weight on the longer arm. So we have to balance object of 100 kept on the other arm in shorter arm. The shorter arm is having 100. So this is my shorter arm. So here the weight is 100. Here weight is 100 gram force. And here the weight I don't know. So I will say it is mass is m, so weight is mg. Here the mass is 100, weight is 100g. So now when I have to put the weight in such a manner that now my balance is in horizontal position, in equilibrium position. So for 40 centimeter and 100 gram force will produce a torque in anti-clockwise, and this m gram force will produce a torque in clockwise. So both these torques will be equal by principle of moment. So what I will get? 60 multiplied by mg is equal to 40 multiplied by 100 g. This is 100 gram force. This is m gram force. So I will get gg will get cancelled. So I will get m equal to 40 into 100 is 4000 upon 60. 1 0 will get cancelled. So I will get 200 upon 3. So that will give me 66.66 recurring. So I can say 66.67 gram force. So I should keep a mass of 66.6 gram force. Then it will get balanced. So you can see in this manner also that shorter arm should have more weight and longer arm should have smaller weight. So longer arm is 60 centimeter, so it is having a less weight, 66, and shorter arm, which is 40, is having more weight of 100. Is it all right? So go to sum number 7. This is sum number 7. He has drawn a figure to us. So part of the work is done for us. So it says figure shows two parallel opposite. So you can see this is P1, this is P2. Both these forces are 7 Newton. They are equal in magnitude but opposite in direction. So they are not equal forces. They are equal in magnitude and are opposite in direction. So we have learnt that they are called coupled and distance between those forces is 4 meters. That is also given in the diagram. So the distance is 4 meters. Point X is lying somewhere between, not at the center. So what I would say, let its distance be A from force P2. Then its distance from P1 would be 4 minus A. So the question is to calculate the moment about X. So force is, now P2 will rotate in clockwise direction and P1 will also rotate in clockwise direction. So both have to be added up. So 7 into A, what I will get? 7 into So I'll get 7A. So I'll get 7A plus other is of force is 7 and distance was 4 minus A. So this is the total moment in clockwise direction. Isn't it? So this is the total moment in clockwise direction. So we'll get M equal to 28 because this plus 7 and minus 7 will get cancelled. So I'll get moment as 28 and in Newton meter because distance was given 4 meter and this was given in Newton. So 28 Newton meter is the moment, clockwise moment that will get produced. Is it alright? So then it says that about y, about where y is here. So distance of y from P2 is 0, so moment is 0 and distance of P1 from y is 4, so it would be 7 into 4, 28. As I told you that moment of couple does not depend upon the point of rotation, it is remains same. So this example shows us that moment is remaining same, that is 28. Is it alright? Now we'll go to next sum. State the effect. Effect is that it will rotate the body clockwise with moment of 28 Newton meter. Then next figure B shows uniform meter rule AB pivoted at end date. So at end date is pivoted, so this is 0. To support the rule, spring balance is attached at end B. At end B, this is a spring balance. So means some force is acting here. Now, at 40 centimeter, he is attaching a load of 20 kg. Isn't it? So, body can rotate about point A. So, as the body can rotate about point A, so what does it mean? So, it means that as the body can rotate about point A, so body will 20 kgf will rotate the body in clockwise direction. 20 kgf will rotate the body in clockwise direction. So the body will be rotated in clockwise direction. So this force, spring force should be up so that it should rotate the body in anti-clockwise direction. So the force at B would be upward so that it will rotate the body in anti-clockwise. Then only this will remain in equilibrium. So it says we have to neglect the mass of the rod. So if you neglect the mass of the rod, so what I will get? 40 into 20. So what I will get? 40 multiplied by 20 is equal to unknown force F into 100. Unknown force F into 100. So as you calculate this, you will get F equal to 800 upon 100, that is 8. So you will get force as 8. So if we neglect the effect of mass of the rod, the force spring balance will read 8 kgf. In the second part, he says that the weight is to be considered and weight is 10 kg. Now this 10 kg will act at center. So 10 kg weight will act at center. It will be also down. So it will also rotate in the clockwise direction. So in the left hand side, this parameter, this value will also come, that 50 into 10 means 500. So this is 800 plus 500. That will give me 1300. So I'll get 1300 equal to 100F. So I'll get F as 13. So I'll get F as 13. Is it alright? Note down. Then we'll go to sum number 9. In sum number 9 says, weights 4 kg and 6 kg are suspended from ends of a uniform rod of length 50 centimeter. So I've got a rod of length 50 centimeter. So this is the rod of 50 centimeter length. And what the sum read? 4 kg and its weight is 5 kg. it is at what point should we suspend the rod. So at one end I have got 4 kg. So here suppose I am taking 4 kg F4 and other end let us take 6 kg F. Then middle point would be 25 centimeter. So their weight of this will act, that is 5 kg F. Now I say, where should I keep my knife head so as to balance it? Now in order to balance this, you first don't consider this 5 kg F. So if I have it at the center, it will not get balanced because here the weight is more, here the weight is less. So when the weight is more, distance will be less. So my distance should be on this side. Knife edge should be on this side. So that if my knife edge on this side, this will reduce, this will increase, and this will also help in increasing it. So my support has to be somewhere here. Let it be at X centimeter from 4 kg. Now you see, for 4 kg F, distance is from fulcrum is X. Then what is the distance 6 kg from fulcrum? So would be 50 minus X because total distance is 50. And what was the distance of this weight from this? So this distance would be, this is 25, this is X and X is more than 25, so it is X minus 25. Now I know all the weights or means all the forces as well as their distance from the knife edge. So I can write the equation. So we'll write taking moment about this fulcrum. So this is clockwise. This force is also clockwise and this force is anti-clockwise. So this is alone and these two are together as we discussed. So it will become 4x plus 5 into x minus 25 equal to x minus 25 equal to 6 multiplied by 50. Equal to 6 multiplied by 50. So this will give me 300. And this you can solve. Now this is Dawson algebra. 4x plus 5x minus 125. Sorry, this would not be 50, this would be, the distance is 50 minus x. The distance of this from fulcrum is 50 minus x. So 6 multiplied by 50 minus x. So this will be 300 minus 6x. So I will get 4x plus 5x minus 125 equal to 300 minus 6x. So bring all x together, you will get 6x plus 4x plus 5x. So that will give you 15x. So 15x is equal to, bring all arbitrary number together. 300 and minus 125 gives you 425, and now this is simple equation. If you solve it, you will get the answer. X is 425 upon 15, that will give you 28.3 centimeters. So this is how we can solve this sum. So we have solved up to 9. Now let us do the 10th sum. This is quite simple. So C force 7 Newton, B is 12 Newton, C is 20 Newton, O is the point about which we want to calculate the moment. So what will the moment of A from O would be 7 into this distance. What is that distance for A? 4. So it will be 28 Newton meter. In which direction? Clockwise. B it would be anti-clockwise. And what is the moment? 12 into distance is 2, 24. And if we take C, it would be again